Hello, I'm going to talk about SNM, Continuous and Scalable 3D Nanoprinting. SNM stands for Scalable Nanomanufacturing. My name is Shen Shu from Mechanical Engineering, and the co-inventor of this technology is Dr. Liang Pan and Dr. Brian Boderis. So everybody knows 3D printing, and what we are trying to do is to do 3D printing with very, very high resolution on the order of 100 nanometer. So what's the use of that is basically many people are doing work in that area and have demonstrated there are a lot of applications that we can use this for. For example, on the upper left, we see something called tissue engineering. So basically, the 3D printing can be used to print scaffolds. And then you can grow tissues or bones and around those scaffolds and to so-called bone regeneration. On the upper right, we can develop materials which is ultra light or very strong. Basically, we can develop those porous structures, but it also has very good mechanical strengths. So it is very light and of course it's very, very strong. On the lower left, we see micro robots, and we can use these to print very, very small robots. On the lower left, these are valves. On the right-hand side, those are needles with porous needles, which used to release drugs over a period of time, for example. On the lower right, we see many of these structures like gears, traphoids, bracelets, so on and so forth, printed in my laboratory by undergraduate students. And this picture actually didn't show up very well. Actually, it is a Purdue drum. We know that we have the largest drum at Purdue, but this drum is like 10 micrometers across in this size. So this is all good. The problem is that these things cannot be printed very fast. We're talking about printing these things over a time period, over maybe 10 minutes, 20 minutes, all the way to maybe hours. So if we want to market this for commercial products, we need to find a way to print these things very fast, and this is what this technology is about. So what is this fast printing technology? If you buy any 3D printer nowadays, the speed is slow. One of the more recent breakthrough in this technology is from a company called Carbon 3D. They invent a method that can print large parts very fast. What we know about 3D printing is that we print layer by layer. Okay, we put on one layer of material polymers, they solidify it, then put on another layer and solidify it. So what they do is that they, in their system, they create a so-called dead zone. This dead zone that printing does not happen. And so the liquid can be continuously flow into this dead zone. And then the printing can be a continuous process. And they have demonstrated printing a lot of things. For example, the shoe, I think is Adidas shoe. So, but the problem of what they are doing is that the resolution is limited to tens of micrometers. So in our technology, we can print small things, as I showed earlier. All these things are small, but we in order to create a dead zone similar to this case, we actually use two laser beams. One laser beam to print, the other laser beam shoot into a region here, create a dead zone in a process called STEP, stimulated emission depletion. So the printing process is depleted in this process, in this zone. So we can continuously print small things. This is actually a STEP 3D printer that is built in the laboratory. Okay, in terms of the legal landscape, we have filed a US patent last year, and we don't have third-party obligations. The project is funded by NSF for a period of 4 years, and this is, we are about 1.5 years into the project. And in terms of timeline, we have, this is a research in progress in a way, and we have demonstrated 2D step printing, meaning depleting and create a dead zone and things like that. And we are developing proprietary polymers specifically for this purpose. We expect that we are going to demonstrate 3D printing welcome you to join our effort.